Okay, question number 5. These are tricky. Or they're tricky to get your head around anyway. Given a simple random sample from a normal population and with mean, mu, and standard deviation sigma, you are asked to conduct a t-test of this hypothesis. So the null hypothesis is that mu is 10, and the alternate hypothesis that is mu is greater than 10, and it's a 5% significance level. And the piece of information we've been given to try and solve that is that the interval negative infinity to 9.74 is a 95% right-sided confidence interval for mu. So let's just have a look what this piece of information that we're told gives. If I draw a number line here, this is going to negative infinity, then what it's saying is that there's a point here which is the right hand side, and this here is the value at 9.74, and there is a 0.95% chance 0.95% chance, a 95% chance that the value for mu is less than 9.74. And now it's saying we want to try and prove that mu, so we know that there's 0.05 in here. Now we're trying to prove that mu is greater than 10. We're trying to prove that mu is greater than 10. Greater than 10, question mark, with a 5% significance level. So can we prove that already? Well, I think we can. So there was only a 5% chance that the value was going to be bigger than 9.74. So there's obviously going to be less than a 5% chance that it's greater than 10. Because there's only a 5% chance that's greater than 9.74. So we're trying to prove here with 95% certainty that it's greater than 10. Well, obviously we can't do that because we know there's a 95% chance of it being less than 10. In fact, more than a 95% chance of mu being less than 10. So this is obviously going to be, we'll not reject H0 in favour. Okay, let's have a look at the next one. So it says, given a random sample from a normal population with mu, mean mu, and standard deviation, so the same thing again, and at the 2% significance level, given that the interval minus infinity to 10.98 is a 98% right-sided, can we prove that mu is less than 12? Let's have a look. So in this case, we got the same thing again. We've got minus infinity to 10.98. Give myself a bit more space in this one. And we're trying to prove it's less than 12. Trying to prove less than 12. So we know in this area here, there's 0.98%, keep saying percent, 0.98 chance that the mu is going to be less than 10.98. So that means this whole range here is 0.02. So what does that tell us about this range here? Is it going to be less than 0.02? Well, of course it is, because it's a subset of the range 0.02. So clearly we can prove that the mu is going to be less than 12 with more than 98% certainty. So I hope that makes sense. It's kind of a tricky one to get your head around, even trickier one for me to draw because I'm not a very good drawer. But basically, if you write down what it is that we know already, in this case there's a 98% chance that it's going to be less than 10.98, then obviously there's a more than 98% chance that it's going to be less than 12. So that's a pretty straightforward way of doing it. So in this case we will reject H0 in favour of H1. And we're done.